first kinematical equation, second kinematical equation and third kinematical equation. If initial velocity of body is given by, or it is u, final velocity of a body is v, t is the time during the motion, and s is the displacement of the body. A is the acceleration of a body. Then first kinematical equation is given by v is equal to u plus at. We have to prove this equation. Then second kinematical equation is s is equal to ut plus half at square. This is the second equation, Newton's second equation of motion. And third equation is v square is equal to u square plus twice as. Third kinematical equation. We have to prove these three equations by describing the relation between velocity and time. We have to prove this equation. If you consider this equation, in that case v is the velocity, u is the velocity, so it is the relation between velocity and time. It is the relation between velocity and time. In that case s is displacement and t is the time, so this is the relation between displacement and time. This is the relation between displacement and time. And in that case, this is the displacement between velocity and acceleration. In the next case, this is the relation between displacement and velocity. In that case, this is the relation between velocity and displacement. S is displacement. Now, we have to derive this relation for equation 1. So, equation describing the relation between velocity and time. Equation describing the relation between velocity and time. For that purpose, if you consider same object of mass m moving with initial velocity u, its final velocity is v after time t, then acceleration related with this one is a, and displacement during the motion is given by s. If we describe that by using graph as like this one, this is y axis, this one is x axis, this is point D. At point D, initial velocity of object is u. This velocity of an object goes on increasing. After time t, object reaches at point B. At B, its final velocity is v. Its final velocity is b after time t. So, along y-axis there is velocity and along the x-axis there is time. So, When it reaches to point B, then time is t. Now we draw the parallel line to the x-axis as like this one. Also we draw the parallel line from D, which meet at point A, and O is the origin. And on the y-axis, this point is C. This describes the graphical representation of a body moving with initial velocity u and reaches to final velocity v when it reaches to point B after some time t. Then its acceleration is given by a and displacement is given by s. Now we know the formula for acceleration. Acceleration is equal to change in velocity upon time. So A is equal to change in the velocity means final velocity minus initial velocity upon time. So we get A is equal to V minus U upon T. Now body moves with initial velocity U. So this distance OD is equal to U. And final distance is OC is equal to V. So we get A equal to OC minus OD upon T. By using this graph, A equal to final minus initial upon time, A equal to OC minus OD upon T. But this OC minus OD is equal to CD. If you consider this graph, in that case OC is equal to V. OC minus OD, that is remaining is only CD. So OC minus OD is equal to CD. Therefore instead of this OC minus OD, we write directly CD. So we get acceleration A is equal to CD upon T. This T on that side will be multiplied, and therefore finally we get CD is equal to AT. CD is equal to AT. In this way we get magnitude of this distance, that is equal to AT. Now, as we know that from the B, we draw the parallel line to y-axis, and at point A, there is another parallel line to x-axis. It meet at point A. Then from this, we know that this distance AB is equal to CD. This distance AB is equal to CD, means the distance is equal to CD. And the distance OD is equal to AE. The distance OD is equal to AE. From the diagram, AB is equal to CD, AE equal to OD. OD distance is equal to U, AB distance is equal to AT by using this relation. Then we get this BE is equal to, distance BE is equal to AE plus AB. AE plus AB. Now this BE, this distance BE is equal to OC, and this OC is equal to V. Here we write OC is equal to V and BE also equal to V. So we substitute here value of V, BE, that is equal to V. AE is equal to OD, and that distance is equal to U. So AE is equal to U. AB, but we know that this distance AB is equal to CD, and this CD is equal to AT. So we substitute value of AB, that is equal to CD, that is equal to AT. So we get first kinematical equation. V is equal to U plus AT, where V is final velocity, U is initial velocity, A is acceleration, and T is the time. So in this way we get first kinematical equation, Newton's first equation of motion, V is equal to U plus AT, by using this graph. Now we derive the another equation, relation between displacement and velocity. So equation describing the relation between displacement and time. Again we consider same graph. In this case we consider this quadrangle. Displacement of object is equal to area of quadrangle DOEB. Means we have to find out the area of this quadrangle DOEB. This quadrangle, for the finding area of this quadrangle, we consider here one triangle DAB and one rectangle DOEA. So we write area of rectangle DOEA plus area of this triangle, area of triangle DAB. For finding the total area of DOEB, we have to measure the area of this rectangle DOEA, and we have to again measure the area of this triangle DAB, and then take summation of both these. Then we get total displacement. Now area of rectangle is this OD into OE. OD into OE. This gives us area of this rectangle DOEA plus area of triangle DAB, half of DA into AB. By using this formula we can find out displacement, total displacement. OD is equal to U and OE is equal to T. So we write OD equal to, from this diagram, OD is equal to U, OE is equal to T, DA is equal to T, and AB equal to CD, that is equal to AT. We substitute all these values in this equation. OD is U, OE is T plus half as it is DA. DA is T. AB is equal to CD and that is equal to AT. By rearranging this we get final displacement, yes, of the object UT plus half AT square. So this is the second kinematic equation or second Newton's second law of motion. S is equal to UT plus half AT square. So in this way we get equation describing the relation between displacement and time. Now third one, we have to derive an expression for equation describing velocity and time. We have to derive an expression for equation describing relation between displacement and velocity. Means this final relation. Now in that case, we consider this area of DOEB, trapezium. In case of trapezium, two sides are parallel to each other. So area of trapezium DOEB, that is equal to sum of parallel side into perpendicular distance, means half of sum of parallel sides of this trapezium into perpendicular distance or distance between parallel sides. Distance between parallel sides. In this way we get area of trapezium. Now this area of trapezium gives us displacement, that is equal to half sum of parallel side. In this case, in this trapezium, this side is parallel to this one. So we have to take sum of this one. OD plus B. OD plus B into distance between parallel side, that is equal to DA or OE. Now substitute value of OD. Again this OD is equal to U, B is equal to V, this distance, this is equal to V, into DA, DA is equal to OE and OE is equal to T, so into T. So we get displacement S is equal to half U plus V into T. Now we know the formula for acceleration. Acceleration is equal to V minus U upon T. By rearranging this formula, T is equal to V minus U upon A. This formula can be rearranged for time, and then we get time T is equal to V minus U upon A. Rearranging this one, we get, or we substitute value in this formula, then we get S is equal to half U plus V into T means V minus U upon A. These 2 and A on that side get multiplied, so we get twice AS, that is equal to V plus U. This bracket can be written as like that, V plus U into V minus U. By solving these two brackets, we get V square minus U square, and that is equal to twice AS. And finally we get, by rearranging this one, v square is equal to, this minus on that side will become plus, so v square is equal to u square plus twice as. This is the third kinematical equation, or this is Newton's third equation for motion. In this way we study the three equations. Newton's first equation for motion, Newton's second equation for motion, and Newton's third equation for motion. Now we have to study about the laws of the motion.